Hello, this is Mrs. Taylor, and I'm going to walk you through how to use your exponent rules to simplify quotients. And what I have here is I have one big quotient as my first example, and then the other two are products of quotients. So I'm multiplying each of these and then simplifying from there. And so to start with this first example here, remember with order of operations, we have to apply this exponent outside of these parentheses before I can multiply or divide. And so what I'm going to do is I'm just going to take it one set of parentheses at a time, and I'm going to apply that exponent to what's inside of the parentheses. Keep in mind that when I'm applying power to a power, I multiply the exponents. And that's really important you remember that it's multiply the exponents, because this 3 has an exponent of 1. And so when I apply this exponent of 4, I'm multiplying the 4 times the exponent of 1, not times the 3 itself. So when I raise 3x squared all to the 4th, I can rewrite it as 3 to the 4th times x to the 8th. And then in the same way, this second product here would become 2 to the negative 3 times x to the negative 9th. And then down here, this 4 would remain the same, except the x would then be raised to the negative 3 power. And so it would look like this. 3 to the 4th times x to the 8th times 2 to the negative 3 times x to the negative 9th, all over 4 times x to the negative 3. And the reason why this can be so challenging is from this point, I have a lot of options. I can combine the x to the negative 8 and the x to the negative 9 on top by adding those exponents. I could combine the like bases top and bottom by subtracting those exponents, or I can move this x to the negative 9th to the bottom to make the exponent positive and then add those exponents. And so you have lots of choices. What I'm going to do is I'm going to go ahead and combine the x to the 8th, the x to the negative 9th together by adding those exponents. And I'm going to go ahead and evaluate 3 to the 4th and go from there. So that leaves me with 81 times x to the negative 1, because 8 plus negative 9 is negative 1, and then times 2 to the negative 3. Now I'm going to, in my next step, combine my like bases here, the x's. I'm going to do negative 1 minus negative 3. That'll give me negative 1 plus 3, which is 2, leaving me with x squared. And since that would be a positive exponent, it'll be written on the top. And then I'm going to move the 2 to the negative 3 down to the bottom to make that exponent positive. My resulting expression would be 81x squared over 4 times 2 cubed. The thing to remember with this is when you are following order of operations, remember exponents are first. So I cannot multiply 4 times 2. I must evaluate 2 cubed first, and then multiply by 4. So 2 cubed is 8 times 4 is 32. The last thing to check on is if you can reduce the fraction. So the question is, does 81 over 32 reduce to a smaller fraction? Well, the factors of 81 are 9 and 9, which factor further into 3 and 3. 32 factors to 8 and 4, which factors further into 4s and 2. So they don't have any common factors, therefore it cannot be simplified. Of course, the other option is just to do 81 divided by 32 in your calculator, then press math, enter, enter. So this would be my final simplified answer. Now, for products of quotients, what you would do is basically the same thing to each of the quotients first, and then multiply across the top and bottom. And so I'm going to apply the exponent of 4 to each of these items inside of the parentheses. And same thing here and here, and go ahead and write that out. So applying that exponent to each item in the parentheses, my result would be this. And then from there, again, I have a lot of options. When looking at this first quotient here, I have no common bases on top and bottom. Same thing over here on the right. Negative 5 to the 4th, I could go ahead and multiply that out, and 4 cubed, I could multiply the 2 to the 4th out. But really at this point, that would just be an extra step to do it individually. So what I'm going to do is I'm going to multiply across the top and the bottom and create just one quotient and smush all this stuff together. So that would look like this. And in addition to that, I'm going to evaluate the negative 5 to the fourth, the 2 to the fourth, the 4 to the third. Go ahead and get those numbers evaluated. And so my result would be 625 times f to the fourth g to the 8th times 16h squared all over 64h to the negative 6 times 2f to the 3g to the second power. So from this point, what I can do is, they're all out of order, but I can see that I have an f here and an f here, g and g, h and h. And so I can go ahead and combine my like bases by subtracting those exponents. And so 4 minus 3 would be 1, and so I'd have f to the first. That's positive, so it would stay on top of the quotient. 8 minus 2 is 6, so that would become g to the 6th. Again, it's positive, so it stays on the top. And 12 minus negative 6, the minus the negative becomes plus, so that becomes h to the 18th. Again, positive, so it stays on the top. And then I can make it a little bit easier to see what's next. So from there, all I have left to work on are my coefficients. And there are no like bases. I have a 625, 64, 2, 16. So basically what I do is I multiply the 625 times the 16, the 64 times the 2. And then the last step would be to simplify this fraction. Also, writing this one is optional. I could take it off my final answer. And so my final simplified answer is 625 f times g to the 6th times h to the 18th all over 8. And so lots of steps, but like I said earlier, there are several different paths you could take to get to this answer. There's several different steps you can skip once you get really good at this. You can kind of see down the road where things are headed, and you don't have to write it all out. It's just whatever your comfort level is when working with these simplifying problems. So the last problem we have here, first thing we're going to do is we are going to apply these exponents outside of the parentheses to everything inside the parentheses. And then after we do that, we'll look at what we can simplify within each quotient and then put it all together. So to start with, I'm going to apply this exponent of 3 to everything in this quotient and this exponent of negative 2 to everything in this quotient. So once I've applied that exponent, my result is 4 cubed times j cubed all over k to the negative 6 times 2 to the negative 2, h to the 10th, j to the negative 2, k to the 8th, all over 3 to the negative 2, j to the negative 2, k to the negative 16. So from here I have a few options on what I can do next. I can take care of all the negative exponents first by changing the ones in the numerator to the denominator, the ones in the denominator to the numerator. So remember that little rhyme, cross the line, change the sign. I could combine my like bases by subtracting the exponents. So either way, whatever I choose to do is fine. What I am going to do is I'm going to move this 2 to the negative 2 to the bottom, the 3 to the negative 2 to the top to get rid of those negative exponents. And then I'm going to combine these like bases by subtracting the exponents for the j's and the k's. So once I've done that, now I have the 3 squared on top and the 2 squared on bottom. And then when I subtracted my exponents from my j's, negative 2 minus negative 2 became 0. So it would be j to the 0 power, which equals 1. So basically, those two would cancel. And then 8 minus negative 16 is 24. So I have k to the 24th. From there, again, I have lots of options. I can go ahead and cube and square, or I can go ahead and multiply across the top and bottom, bring it all together in one quotient. I can move this k to the negative 6 to the top. Whatever I want to do next, I have lots of options. And so what I'm going to do is I'm going to go ahead and cube the 3, square the 3 and the 2, and then also bring it all into one quotient, smush it all together, all in one step. And so 4 cubed is 64, 3 squared is 9, 2 squared is 4, and then I just multiply it across the top and bottom. Now what I can do is I can go ahead and multiply the 64 times the 9, and then combine these like bases of k by doing 24 minus negative 6. Because 24 minus negative 6 is positive 30, that would leave the k on top. And then the last thing I need to do is make sure that this 576 over 4 is in its reduced form. So if I divide 576 by 4, I get a whole number, 144. So all of this actually just reduces to 144. So that means I can get rid of the denominator and just have this numerator as my final answer. So my final simplified answer will be 144 times j cubed times h to the 10th times k to the 30th.